I'd like to show you a technique in StarNet that allows you to perform sort of a best fit between field measurements and cadastral records. So I'm using Microsurvey CAD just to show you an example. What we've got, let's imagine we've got this lot here, and here I've got the bearings and distances, meets and bounds from an old plan, and you can see that it's on a bearing basis that has 1 to 2 as being north 10 degrees east roughly. And then over here in this example we've got some field work in which these same lot corners were tied in, but you can see that the bearing basis is quite different. And here I'll bring up the traverse editor just so you can see how they were computed. I'll there re-coordinate. There you go, and you can see how what's happened is they've assumed a back sight on this 101 to 100 line, and then they've shot in the corners that they could find, but they were missing this point in here, which in this drawing is called 0.5. And but at least they've got much of the information. And of course, this is shown as a traverse, but this could also take the form of either GPS measurements on evidence that was found in the ground, or even manually entered coordinates, and you can use a number to weight them. And so I'm going to show you how to use a special traverse mode that's built into StarNet called Mapmode on Angle Calc. So let me switch off Microsurvey CAD, and I'll switch my license over so that we can look at this project in StarNet. Switching my license. So now I've got that same data set opened up in StarNet. And so what we have done is from Microsurvey CAD, I've just exported the traverse. So we can see we've got the points 101 and 102 here. And it'll be important that I switch these SS records to M records because we're going to make use of them. So I'll actually use a search and replace. Search for SS, replace it with M. Those are done. And so what you'll notice is this is 3D data. So we've got a .3D here. And I've stopped it at .data off just so that we can process just those points. So I'll pick on yes. And so what I've done is I've also renumbered the 2 points so that they're using exactly the same point identities as were used in the CAD drawing that you saw before. And so now, here we've tied in all of the corners except for that 0.5. And just to show you an alternative way that we could have done this, I'll move the data on down a little bit lower. If I, for example, had some old coordinate values for this 0.4, I could have handled it this way. I can comment it out, and so notice I've only got a northing and an easting, and that's okay. And so because I've got a 2D to tell StarNet that it can only expect X and Y values from here on. And so what I've done is I've input those old record coordinates that are fairly rounded off to the nearest foot, and I'm effectively putting in a weighting here. I'm effectively telling StarNet that I'm confident within about 10 feet of that position. So that would be an alternative way of telling StarNet where roughly to look for 0.4. So I'll leave that on, and then I'll just move this data off even further down. And now what you see we've done here is, first of all, I've typed in a map mode on angle calc. And so what this is this is an inline that tells StarNet to change the way it interprets the traverse file. What we're looking at here is a regular traverse set, and as you can tell, I'm inputting bearings, and these are bearings that come right off the plan that I was showing you before in Microsurvey CAD, and of course distances between the different points. So starting from 1, it's north 10, 10, 10, 250 feet, to point 2, starting from point 2, and so forth. And then we run all the way through, and this traverse happens to tie back in on 1, so the TE line just tells that it closes in on point 1. And so now that I've entered the traverse as, in this case, bearings, that's what map mode on will tell StarNet to expect. This angle calc is yet another modifier on map mode, and what that tells StarNet to do is don't pay attention to the absolute direction that's indicated by that bearing, but instead just compute the angle between each of the bearing lines and treat it as an angle. And so this effectively allows StarNet to treat that old record plan as a kind of a relationship between the points, but it's going to let the position and orientation from the fieldwork rule where it runs the computation. So now that I've got that all set up, I've done everything right, I should be able to adjust it. And now we can see that it has applied the traverse. And remember how before we were missing point 5, and I've also commented out the shot to point 4, but we've given it a position here, although it's actually not even necessary. And what it's done is it's computed where point 5 would be, and you notice how it's completely reoriented that traverse from the way it appeared in Microsurvey CAD, where it was 20 degrees clockwise from where things are now. And if we go into the listing and we take a look at what StarNet has brought in, if I look at the summary of unadjusted input observations, we take a look. So all we've got is angle observations and distance observations. Notice how it doesn't have any bearing observations. And if I go in there, you'll see that it has, of course, computed the observations from the angles from the M lines that are up here, but it's also derived angles from all of these shots, and that it's getting that information from down here. And so it's just computed the angle, and it's computed the traverse using only the angles. So there you go. And like I said, there's multiple ways of inputting those field measurements. They could be just regular traverse information. They could be weighted coordinates. If you had GPS vectors, you could have ties to the evidence that you have found on the ground. And you'll notice how what I've done is I've used inlines in order to differentiate between 3D and 2D data. Because this old plan only has 2D data, you'll find in my project that I'm just running this as a 2D adjustment, but it was able to accommodate the 3D data when I used the .3D, and then I switched it over to 2D for my coordinate input, and then it stayed in 2D while I input the traverse information. There, this is a very interesting technique that can kind of open your eyes as to what you can do with StarNet in a cadastral setting, and I hope that this is useful. Thanks for watching.